Okay, welcome to part 4. I'm glad you're still here. It's very interesting to me. Hopefully it is interesting to you also. So, we've been talking about 3D printing, and recapping once again, we know that 3D printing is done by building layer upon layer. We also know that we can get finer and finer detail, more complex shapes with not only the technology behind the machine, but also with different nozzle sizes and different settings in our slicer programs, and just general advancement in our capabilities of our machines. So you may have said to yourself, I know I did, it's like, great, I can make trinkets and I can make little action figure toys and stuff like that. So the question then becomes, what kind of actual practical use? If I wanted to replace a battery cover that I lost or maybe I broke, and that's all well and good, but what actual good do these things do? One of the biggest things that has a direct benefit from 3D printing, and it's kind of odd and it's kind of weird, and to be honest I find it a little freaky, is the medical field. Medical field benefits greatly from the ability to 3D print something to make it very customized given the application. So my mother-in-law actually showed me a video of where they had a toucan bird, and his beak was actually broke, and somebody actually 3D printed the rest of his beak, and they were able to attach it, so now the bird can, carry about his daily life and, be able to eat and function before it suffered this injury. And then, of course, you have different internal components, as freaky as it sounds, inside the human body, and with the different materials and stuff that can be 3D printed, then we can, and I keep saying we only because I'm starting to become part of this maker community now, but we can make those things and make them functional, and it could be a benefit to people. Now, I would probably the most straightforward example would be maybe an amputee. We could actually 3D print whatever's required as far as maybe a limb. So the technology and the benefits from 3D printing are definitely there, and I have no idea all the aspects that they can encompass because I'm learning as I go. But anyway, that's my rambling about 3D printing. So let's not bore you anymore. Let's go ahead and jump into Tinkercad. Like I said, it's online, tinkercad.com. It's a really basic 3D design software, but even being basic, it has a lot of options and stuff you can go into, and you can get more and more advanced. And as always, I'm learning as I go. So anyway, we'll go ahead and jump into it. I do have an account, as you see here on the screen, and I do have some designs, but I'm looking to create a light box for my lithophanes, and I had already designed one size-wise, but I need to do a new one. So I'm just going to come over here where it says new, and I'm just going to choose a 3D design. Okay, so now I'm going to warn you. We talked about X, Y, and Z axis-wise. So that's all three-dimensional. So when I move the camera, I'm going to try not to give you whiplash. Try to help you understand as we go. But when I move the camera, you'll see the three-dimensional aspect, I guess, for lack of a better word, that I'm talking about. So I'm just going to move this. Now it says work plane, And just think of that as maybe our build plate. That's our like ground level that everything is going to be built upon. So as you see with our plane, we're actually able to look at it from different angles. Now if I were to come over here to my shapes and just drag a simple block here, you can see a little better now how it's three-dimensional. So like I said, this is a very basic design program. So I have this here. Another thing you have to realize is a lot of times when you're dealing with especially 3D printing, everything seems to be done in millimeters. So when you're trying to convert from standard to millimeters, there's a little bit of a learning curve there as well. But anyway, let's continue with my light box that I need to make. So I'm working on a size of 3.5 by 5. I have a simple solid cube here, and I need to change my sizing, so I'm just going to click on the corner here and I'm going to change my sizes. So I know a 3.5 by 5 needs to be 89 millimeters by 127 millimeters, but I need my lithophane to drop inside of that, and if my lithophane is 3.5 by 5, then my box needs to be a little bit bigger. And I've kind of got to the point to where I like it to be 4 millimeters thick along the rim, so to speak. So I'm actually going to take and double that, because it's 4 millimeters on one side, 4 millimeters on the other. So I'm going to take my 89 number and I'm just going to add in 8. So now I know this needs to be 97. And my other number here for the 5 inches is going to be 127 millimeters, but I need to add in my 8. So now it's going to be 135. So now my block is huge. And once again, I'm just going to reposition on my plane here. And as you can see, it's flat. It's not up in the air or anything like that. Over here, you can make any one of these shapes what they call a hole, or they have a couple common ones already done for you. So once again, I'm just going to click on another cube. Now this is going to be the cavity I'm going to create into this block of, let's just say, plastic, because that's what it is. But this hole needs to be the exact size of my lithophane. So once again, I'm just going to make it its actual size, which was 89 millimeters by 127. Oops. Okay, so now I have a block which is a hole, and I'm going to position this into the center of my solid block. All I'm doing here is just taking a look around the rim, visually just looking to see if I'm about centered, which it looks pretty good to me. So now, this being a three-dimensional field, I have different points here, and I'll get into all that stuff later in different videos. I'll do a whole series on designing in Tinkercad. One of our options is to actually elevate this off of our flat plane. We'll call it 0 point. So I can click on this arrow and I can essentially drag it up in the air, and you'll notice down here in the corner it tells me where I'm positioned off of my 0 plane. And I like my rim here to be 4 millimeters. I also like the back, because the back is going to be solid for me. I like it to be 4 millimeters also. So I'm just going to raise my hole up 4 millimeters. And there it is, 2, there's 3, there's 4. So now I've created a cavity inside of it. And what I'm going to do is select both of these items. I'm going to come up here and I'm going to hit group. And now, as you see, it has created a box that has walls now. I also have what will be the back. Right now is the bottom. And everything is 4 millimeters thick. So I'm going to go ahead and cut this video short because the next one is going to be a little bit longer for some of the design details we're going to do. So if you're up for it, there will be a part 5.